Hi and welcome to this tutorial. Today we're going to look at sending. I've stumbled across this kind of nifty thing. I'm sure it's been done before. Nifty way to send an audio buffer through the network. A few of my students were asking if you can do this, and I thought, yeah, it seems like it's something you can do. But it turned out there was a couple curves in the road, and I'm happy to have figured this out. So yeah, so basically this allows you to record a buffer into Supercollider on your computer and then send it through the network conceivably anywhere in the world, and then they could use your buffer. So if you're doing some interactive sort of live performance, you can record buffers and send them around to the people to process or do different things. So it's kind of a nifty thing without using sort of like network audio, that sort of thing. Okay, and it's, obviously it's not immediately real time, but I'm sure you can tweak it so it's pretty close to being real time and just a way of sending sound files to each other. All right, so let's get started. First, I'm just going to go through the basics of setting up a sampler or sample player. You can go ahead and skip ahead in the video if this is familiar to you, or stay in and check it out. So we're going to set up, and I'm just going to pop back and forth between my code and this so I have things consistent. So I'm going to set up a buffer, my buff, and then I'll equal to buffer. I'm going to allocate LC, and it's going to be the server S, and the number of frames is going to be the s.sample rate, okay, which most of the time is 44.1 times a number of seconds. So I'll just make this kind of longish, 13 seconds. Okay, so that's just going to be an empty buffer allocated 13 second long, and it just needs to know the number of frames, which, so that's, if it's 44.1 frames a second, then times 13 seconds. That's how long your buffer is going to be. Okay, and let's see, what's the next step? All right, so then all right, so all this destination stuff, but let's set up the sample player first. We'll call this we'll just call it the same thing. We'll make a buff record, a synth-def, and we'll call it this buff record with a phaser. Set up my basic structure. Okay, so that's our synth-def, and in this case I'm going to use buffer write, buff WR. So let's go ahead and set that up, bufwr.ar. Okay, and it's looking for your input array, buffer number, phase, and loop. So basically this is just sort of it's kind of like, I describe it like a write head on a, if you're old enough to remember tape machines, kind of like a write head on the tape machine. I mean, you can imagine the tape passing by the write head and it being recorded onto. In this case, it's kind of like the write head moving along the tape, right? So you have it's gonna write into something, but then you need an indexer, this phase, and that's where it is. It needs to sort of glide along the tape so that you're recording new stuff on new parts of the tape, okay? Or in this case, into our digital memory. All right, so the input array, we're going to have, well, let's set that up. We're going to have a mic in, so let's set up some varies here. We'll have in, and in will be equal to sound in dot oops, and it will be IBS, the input bus. So we'll make a argument there, and IBS, and we'll just set it equal to 1, 0 as default, the first channel coming in, and this will be the in signal coming in. The buff number will be buff of argument, and the phase, now we're going to set up this we'll just call it index, INDEX, okay, and that should do for the buffer write. So let's set up our index. We got to set up a var for that variable there. Okay, and IBS we already have, and then a buff here up here. That's an argument. Let's not forget that. Okay, so we need to know what buffer to write into, which will be my buff up here eventually. Now, just let me just cheat here and make sure. Oh, and we have an envelope too. Oh, okay. Oh, I guess that would make sense. Okay. Right. Okay. So we need to set up our index first, and we're just going to make it a phaser. K.AR. So this is this. It just continuously generates a signal from 0 to 1 over a certain amount of time. Trig, do I actually use a trig? No, 0. And then the rate will just be 1. We'll keep it 1. That's simple. Start and end time will be its normal start time will be 0. And the end will be this. Oh, I'm sorry. I do need to do this buffer rate scale, right? Start or end. I guess I'm allowing myself to play different parts of it to record different things, but we don't really need. So we'll just say 0 and end buff frames. Do I need the buff rate scale though? Must need the buff rate scale at some time. Rate, sorry. I don't believe we need a, because we'll just keep it at that normal start time. And then we're going to do buff frames. Is it KR? And then buff. Okay, and I believe that's correct. Sorry, I just keep popping back my memories on what it used to be. All right. Okay, so yeah, I'm going to keep this quite simple. Just go from a start to an end. So buff frames will be the number of frames in our buffer, and it's going to go, the phaser will just index from 0 to the total number of frames, and it'll write through there. Okay, and is there a loop kind of function? I guess it's automatic. Oh, yeah, automatically loops. It's a phaser. All right, and then, right, so buff, and that works, and that's good. And then we are going to have an envelope. And our envelope is going to be equals .ar and env.asr. Let's use ASR, and we'll just do just so it doesn't have a little clippy thing. So we'll just use the default attack, sustain level at default REL EASE time. We'll make that a little bit shorter, 0. Say a whole tenth of a second. Yeah, that's fine. Okay, so that's the only thing we really need to change there. And then we'll have a gate there so we can turn on and off our envelope. Oh, and then we'll have a done action, so we'll have it kill itself. A done action 2 means that when we shut the envelope and it ends, it just takes that synth off the server. Okay, so then we don't have to worry about it. So we just set our gate to 1 and then to 0. So we'll start recording with a gate 1. So we'll have gate, the default, be equal to 1. Okay, and if this is all new to you, I have other videos that talk more in depth about envelopes and other things. I'm just going to kind of quickly go through this. Right, so we have our envelope generator, envelope, gate, everything's all good, and we just have to times that by the envelope. The in times the envelope, the buffer is going to be written to, and it's going to be indexed by the index. So let me see if I boot that. Let me see if this, yeah, that's all good and good. Okay, so now we're going to make something very similar. So I'll just copy and paste, and this will be our buffer buff play phaser, or what did I call it here? Buff PL, buff rec and buff PL, buff rec and buff PL. Okay, and very much same, except I think I add an out bus instead of in bus. Yeah, right. So this is OBS. Okay, and the envelope is the same. Instead, we're going to play. So we want to play back. We want to buff read. So we don't have an in anymore. Get rid of that. Okay, and we're going to read our buffer, and it's going to be number of channels is, we'll set it to 1. Buff number is going to be buff, and then the phase will be this index, and then we're going to loop it. And well, it's default to 1, so we'll just leave it there. All right, and what else do we need? We need the buff read, the phaser. So I guess I'm letting myself do a rate and a start and an end, so we can do that. Envelope generator, and that's it. Okay. Right. I mean, you might as well have for the playback anyway, so we can have a rate and a start in case you want to play some of the sample and an end. Okay, and we'll make end equal 1, start equal to 0, and the rate by default equal to 1. Okay, and buff read, is it in? No, it's in the thing. So this will be phaser trig rate will be rate, and the start will be start, and then this is multiplied by, we're going to need to get the buff UF rate scale, so it just gives a sample rate dot kr buff. Okay, kind of trud along at the proper divisions of the sample rate there, and then this is end times buff frames for that. This is the end time. So n times, I think actually it's a buff rate scale instead of buff frames. Oh no, it's buff frames. KR buff. Right, because if it's 1, it's going to be the total number of frames in the buffer. If it's 0.5, it'll be half the frames of the buffer. It'll go through halfway. Okay, so if I make that slightly, shrink this text slightly bit so you can see it. There we are. Okay. All right, so that's our playback synth. Okay, that'll play back. Oh, and we need to send it out. So we're going to do a out.ar, and it will be our right. So this is our sig. We need some kind of signal. Okay, and signal will equal the buffer read equals that. And then we'll send that out. Out will be OBS, and it will be the sig. Okay, and there you go. And let's just evaluate that and see if it works. Great, fantastic. Okay, now we're going to get down to the nitty-gritty. This is probably the part you've been waiting for. And this is really, I'll talk you through it first. This is really what we need to do to send this buffer through the network, and so that another person on somewhere else can use it. Basically, we're going to take the buffer here that we've recorded into. We're going to convert it into a float array, just this giant collection of floating point numbers that represents, that many samples, so 13 times 44,100. And then we're going to send it through the network. Now, one of the things I ran into was that the UDP, the way the protocol, I guess, that we send things through the network in, or one of them, has a packet limit. So that's the internet works on these little packets, as far as I understand, and there's a packet size limit. All right, so basically, I have to break that giant float array into chunks, send them out as chunks, and then have a receiver on the other end smart enough to know that, give it a couple tags saying, I'm sending a bunch of chunks. You're going to take the next few bits of chunks and then piece them all together and then convert it back into a buffer. Okay, so that's what we're going to try to do. So I'm going to have to pop back a lot here. So I'm going to create a function. I'm going to call the send buff function. So, well, let me create the net address first. We're going to create a PRO, let's see, what did I call it? Netdest. NETDEST. We're going to create a net ADDR, a net address, and the host name. We're just going to keep it a local host right now, but you put in whoever IP you want to, that's 0.0.1, and then the port number, which for us is 57120. It's just the local thing. Okay, so now what we're going to do is we're going to create a function, and again, what did I call it? Send buff function. Send buff func. Okay, and so then we can just run it as a function in those curly brackets. Okay, so the main thing we're going to use is this .load to float array. Okay, so .load to float array. Okay, and then within it you have this thing action, and then that's another function. Okay, it's a bit of a thing. There's a lot of little things there. Okay, so basically you have some kind of buffer, which is my buff in this case. This is the buffer I'm recording into. My buff. Okay, and then it's going to run this function, load to float array. So basically you're converting this buffer into a float array, but it all happens within this action and then another function within that. Okay, so that's all happening. All the action is happening in action. Okay, so let's go ahead. Just I guess this is just to keep all our curly brackets and everything in order. All right. Okay, so what do I do first? We're gonna make a couple of variables and arguments. But first, let me just start this variable. So one of the things I need to do is I need to break up the thing into smaller chunks. Okay, and I sort of just did some tests, and wasn't very scientific, but I think pretty close to the biggest one is going to be at least at 44.1. So I suppose this is not the best line here. We have to adjust that, but at 44.1 sampling rate, you're going to send about a quarter of a second. Okay, so I'll just keep it that way anyway. So I'll say PKSZ equals 44.1,000 times 0.25. So this is sort of the maximum. I'm sure I can do some really minimal research and find out exactly how much, but that's about as big as a packet should be there. Okay, and it's fine. And then we're going to find out the number of packets. So buff AR is the buff array. All right, okay. So this is one of those deals where the action has a built-in argument. Okay, just like kind of a message on the OSCdefs. So the argument that comes in is going to be the actual array that this has been converted to, your buffer being converted to this float array. So that first argument is going to be that actual array. So we'll say BUFAR. Okay, we're going to call it the buffer array. All right, so that's coming in. We've calculated the packet size now. Now we're going to calculate the number of packets. Okay, so we're going to say num packets. How do I spell it? I just want to keep everything consistent. PKTS, num PKTS. Okay, and then we're going to calculate that. So the number of packets is the basic packet size, right? So the total size of our array divided by the minimum packet size, or the maximum packet size. So that's buff AR.size. That's going to give us the size of this large float array from our buffer. And we're going to divide that by PKSC, the packet size. Okay, and I believe that's... And then we're going to make it an integer. Okay, we're going to make it an integer so that we have a whole number there so that we can run a loop on that, .ceil, right? So we'll just round up. Okay. So basically, we're going to take the number of packets that will contain the whole float array. All right, and then we're going to split the arrays up. Okay, so we're going to do this split array. So I guess I need a variable called split. Split arrays, is that what I call it? Split arrays. And then I'm going to create a new array based on the number of packets I need. Okay, a new empty array. So I'm going to go split equals, and in order to, there's this convention to make multiple numbers of something. So if I do an array of multiple somethings, so if I do something like, I'll just do it locally here, like 2 exclamation point 9, it's going to create an array with 9 slots and 2 in each slot. Okay, so that's how a sort of shorthand for creating an array of multiple things. Okay, but when you're doing things like new arrays, you have to put it in a function. So I'm going to do an array new clear. Okay, so I'm going to do an array dot new clear. So that's a new clean array, and I'm going to make that array the packet size, PKSC. Okay, and then encapsulate in the function, and then I'm going to exclamation point that number of packets. Okay. And that's going to create, so let me just talk you through that. So basically, we found out the maximum size of our that the UDP packet can handle. So we're going to create an array that size to handle part of this total array. Okay, and then we just calculate the number of those little packets that we need by taking the total size of the array, the buffer array, divided by the maximum packet size, or the maximum amount in our array that, so it's basically 1/4 of 44.1 about. It's, that's like I said, that's just an experimental number. I just messed about changing. I couldn't be bothered to do the 2 seconds of research it would have probably taken for me to actually find out how the maximum limit of a UDP packet. And then I rounded it up so that we make sure we have a number of packets. Now I made an array of arrays, a 2D array, so filled with arrays of the maximum empty arrays of the maximum packet size, right? So this is array nuclear packet size. That's going to make an array of that size, and then the exclamation point is going to multiply it by the number of packets. So that's how many packets. So now I have an array here of arrays, a 2D array that's containing exactly packets the size I need and the number of packets that I need. So that's what we have. Okay. So now I do this fork thing because we need to sort of pace some things out. So let me see where that goes. Where does this go? And then right to the end, huh? Yeah, okay. So now we're going to use a fork because, fork gives us a routine and allows us really, the main way I use it anyways in this case, is allows me to put some timings in because I'm asking the computer to chug a lot of numbers and they have to do it sort of in order. And so there's some errors that happen. So I make sure by putting some pauses in there, I can use fork to put some pauses in so that I make sure that one process gets done before the next gets started. So if I use fork to create a routine and then just end that there. So everything in fork now, I can put these timings in. Okay, that just allows me to put these timings in. Okay, so the first thing I do is I make a starting to send message. Okay, so the three-step process, since it's this kind of sort of complex thing of splitting it up into little packets and then sending it and then making sure it's received. So I'm going to give a little message saying, okay, now I'm about to start sending you stuff. And then the next messages will be all the stuff, and then there'll be closing messages. I'm done sending you stuff. Okay, so that's basically, so we're going to say make a starting message. I'm sending you stuff. You lots of stuff. Okay. All right. So, and what I'm going to do, okay. So I do a receive SAM 0. Okay. So I use this netdest net address, and I'm sending .send msg, and I'm sending a message called what do I call it? Receive SAMP. Is that spelled with I before E except after C? So receive EIVE. Okay, receive SAMP, and I'm going to send a 0 as a little, and you'll see on the other end as a little tag, as a little keyword. So when it sees that 0, it knows this is the starting message. This is the initial, I'm getting ready to send you stuff. Okay, and then I'm going to do a little wait. So this is this fork thing that helps me. So I'm going to do 0.1, a tenth of a second dot wait. So that gets done first, and then it waits before it sends some other stuff. Okay. And then the next thing I do is now I'm going to run a for loop on the buff array, and I'm going to do some really fancy stuff. I have no idea what I'm doing here. So let's see. If I do the array, I'm gonna fill these split arrays. That's right. Okay, so I'm gonna populate the split arrays, the small arrays, the packet size arrays, with what's in the buffer. So let's make a little header anyways. Populate smaller packet size arrays with larger with values from larger larger buffer. Okay, so let's make that slightly smaller so we can fit. Okay, so what do? We run a for loop or a loop on the larger buffer array. So bufar.do. Okay, and basically these come in. You have two when you do it on an array. You get two arguments there. The first one is the actual item in the array, and the next one is an index. So I call it an it and an x. Okay, so we'll do that, and then what do? We have it x, and then we have there's an inc here for some reason. I'm sure that's going to be quite useful. 0.01. I make an increment here, I guess, because I need to independently increment something as well. So we're going to make a var inc. Okay. And what to do? Blah blah blah. Oh, look at this. IXS equals. Okay, so actually, instead of popping back and forth, let me just copy this stuff. Oh, and I forgot the parentheses here. So, and then I'll actually just leave that there. I'll retype it just to. So actually, we need this buffer array. This is like that. Okay, we need those extra brackets there. Okay, so I create this variable here, IXS, in another index, equals IX modulo PKSC. KSC. Okay, so so I'm going to make this variable IXS. It's going to be indexing thing, and it's going to actually equal to the index modulo packet size. Okay, so basically it's a little counter that I made that's going to go through all the indexes of the entire buffer array. That's a new array that's made of all the values in the buffer, except it's going to reset. It's going to go from 0 to packet size, 0 to packet size, so that we have, so that we have that much into one thing, and it's going to advance every time. Okay, so we have this IXS, and then we're going to do this. I don't have the pop back now, so we use that line. So we're going to do this if statement. So we're going to say if, and we're going to say if the IX, that's the index number of the bigger buffer, try to follow here, and it's a bit of a mind bender, it's greater than 0, because we don't want to do it on the 0 one. And I don't know why I put in parentheses. IXS is equal to 0. Okay. Right. Okay, so we're not doing it for the first one, the very first one, but if it resets, it goes to 0, then we're going to increment this inc. That's why we have this inc 0. We're going to say then, in that case, and I'll tie this all together later, equals, and we're going to increment it, inc plus 1. Okay, so we have something that advances every time we have a new set, because we want basically to fill that set with what's in here. So every time we have a new, a new packet size worth of data, this is going to become 0. So then IXS is 0, and then inc equal inc. So we don't want to increment it. We're going to start with 0. That's why we don't do it on the very first one. We're going to start with 0. We're happy to have it 0. Okay. And I think that's it for the if statement there. All right, so we did that. Okay, and then we just populate the split arrays, right? So each of our split arrays now, again, it has an array of a packet size and has that many arrays. So it has an array of the maximum packet size, and it's an array of time. Can't speak here. So it has that many number of arrays of that packet size, right? Of the maximum packet size. So we're going to populate that split array. So we're going to say split arrays inc. So inc is a 2D array. So the increment is this inc. Okay, that starts at 0, and then it goes to 1 after packet size amount of things. So basically, split arrays 0 will stay 0 until we reach packet size worth of values, and then it'll go to 1. So we populate the 1, which makes sense, right? So we have number of packets of these arrays, okay, and then we're going to just increment through those. I don't know if I explained that the best, but IXS, hopefully you kind of get it. And then IXS is going to be this modulo. So it's easier or practical. Let's just make the numbers much smaller. Let's say the maximum amount of values we can set is 10. And let's say we have a buffer that is giving us 100 values. Okay, so this is basically saying every 10 go back to 0. So this is going to count 0 through 9, 0 through 9, 0 through 9, 0 through 9. Okay, 10 times, right? Because this index is going to generate that. So this is, as this is going up, this is going to go from 0 to 99. 0 will be 0, etc., etc. 11 will go back to 1. This is still going up to 99. 12 will be 2. 13 will be 3, etc. So that resets that. This goes 0 through 9, 0 through 9. And this is saying we're not going to do the first one because we want to keep that 0. We don't want to increment it. And this is saying that, and if this IXS is 0, if it equals, then we're going to increment this inc so we can advance a set. So if this is 9, it's going to be whatever, 1. And then if it becomes 10, it becomes 0. So 0, we're going to advance that increment, and so this will move that. So this will be populated with 10 of these values, and then it'll move to the next one in the array of arrays, a 2D array, the next array, and then it'll populate number 2 or number 1, whatever, the second one with 10 of those values, and the third one with 10 of those values, and the fourth one with 10 of those values until it gets to all 10 of them, and it populates that. So basically, we're taking these smaller arrays and populating them with chunks from this bigger array. Okay, and this is probably a more elegant way to do this, but this is what equals it. Okay, so it is the value in the actual buffer array. Index is the index, and that's the value. So whatever is in there at that index number will be stuck into this split arrays. Okay, and then it's going to move forward. So that's how that's done. So it's actually pretty straightforward. So this basically just does what we say. It populates the smaller packet size arrays with values from the larger buffer array. Just splits them up into smaller arrays. Okay, in a nutshell. And then this is the part where we then send off our packets. Okay, so I'll copy that over as well. I think I have a lot of weights in there. I'm not sure I need that many weights, but oh well. Okay, and then I'll okay, so we'll walk through it and we'll type it. So now that we have these populated split arrays, we're going to run a loop on them. So we're going to say split arrays dot do. Okay, and it's got the same sort of parameters. Got an it and an x. So and this is shorthand for arguments. You don't even need commas. We're just not an it and an x, the two lines like that. Okay, and then we have this. I created this variable which I'll need a var new buff, and we'll get to what that is later. So the first new buff is going to be an array dot new from it. Okay, so basically this makes a copy of an array. All right, so this new buffer will be a copy of the array it. Now remember, a split array is a 2D array. It's an array of arrays. So each one of these split arrays will be another array. The it will be an array. So this new buff copies that array, this it. Okay, copies that array, just makes a copy of it. Okay, now we're going to insert some things. So new buff equals itself dot insert 0-1. So we're going to insert in the 0th index, or the very beginning, the number 1. Okay, and that's simply like this tag up here, this receive samp, this tag right here. It's going to tell you that this is the second part the second stage of what we're doing. So our receiver is going to receive, say, 0. Okay, I'm getting ready to send you lots of stuff. Then it's going to get a 1 saying this is the stuff. Okay, so I guess really the header here is we're going to send you stuff. Okay, so it's this is going through all these arrays because remember we have a maximum packet size. So it's going to take the first array, it's going to copy it, and then it's going to insert this tag, this one tag. All right, and then so we got this bit done. Insert the one tag, and then it's going to insert before that the actual header. So new buff is going to send the OSC name. Insert. So again in the 0 in the very first position, we're going to send in this OSC address, which is RECEIVE SAMP. Okay, and that's the actual tag or the name we're sending it under. Okay, then we're going to send it. So finally we get to sending it. We're going to send this one packet, and remember we have to send these bundles. We're going to use a send bundle. Send these packets one at a time, one after another, because that's the maximum size. So netdest.send bundle. Okay, and then we're going to send it. This is just a time tag. Send it right away. It's not going to wait. And then new buff. It's going to send that array. Okay, as a bundle. All right, and then at this point we're going to wait a second before it goes to the next array. We're going to give it a little time for the receiver to receive it. Okay, so do a tenth of a second, 100 millisecond wait right there. So before it does the next array, so it's going to send one of these split arrays, and then the next one it's going to wait, and then the next one, and then wait, and that's until it's done with all of them. Okay, great. So did I need this one? Is this extra? Fork. That's the fork there. Okay, so I don't need any of this stuff. Okay. All right, then what's next? Let's see. So we've sent those arrays. Now we're going to do a little wait, and we're going to do a done message. Okay, and then I'll show you how we receive that. So that's the split arrays. We need a semicolon there, and then we're going to wait again. So I'll just retype all this. So let's actually select all. Let's go auto indent. Okay. Okay, and finally we're going to send a done message. So we're going to wait a little bit, and we're going to send this done message. So I won't retype this. It's this net destination, and we're going to send a message, and we're going to say it's all under the same thing, receive SAMP. So we're going to receive it all in the same sort of thing, but we're going to parse out the things. So we're going to say receive SAMP, and then a little tag 2. So you notice that this one was 1, this one up here was 0, and then this one is 2. So all the 3 stages of our little process here. Okay, so let's just have a quick review. I'll shrink this there and just go over the section. So basically, we're creating this function, okay, and it's going to take the buffer and it's going to make a larger float array out of it. Okay, and it has this weird syntax where you have to do all this stuff in the action. Okay, it's an automatic argument here, which is the actual buffer converted into array, and that becomes that first argument. All right, and then we do a number of things. We do some calculations. We find out the maximum packet size. We find out how many packets are in that actual buffer of that packet size, and then we create an array of arrays, a 2D array that contains number of packets worth of arrays that are packet size long. Okay, then we do this fork so we can put these little weights in. And we send a starting message saying, okay, get ready, I'm sending you lots of stuff. And then we do these 2 for loops. One will populate the split arrays things with the values from the larger buffer array. And then this second will take those populated arrays and run loops on them to send them each as its own packet. So the first array that's the right size will get inserted a tag and then the actual OSC address. It gets sent as a bundle, and then we wait a little bit before we send the next one. Then after this is all done, we wait again a little bit. I don't know, this is might be redundant, but it's tenth of a second. You're not going to notice it. And then it sends a done message saying, okay, we're all done sending. Now you can compile all that stuff you received. So you can send this long thing. So there we go. So we got that function done. That's going to do all that. Okay, so we just have to run that send buff function. Okay. Now we need to deal with our OSCdef. So this is the receive side. All right. So we're going to do a receive side, and we'll pop that in there. Okay, and then let's just auto indent everything. But I will go ahead and type through this stuff so we can see it. So let's grow that back to a viewable thing. Okay, and so we're going to make an OSCdef. So OSCdef, open that up, make a key, which will be receive samp. I think I keep changing my spelling. It's I before E except after C. Oh no, yeah, that's right. Okay. Okay, and then some kind of function that's going to run when we receive it. And then it's going to be the tag receive samp. Oops, /. Right, okay. And that harmonizes with what we have here. This is the message we're actually sending, receive samp, okay? And then that's the end of our OSCdef right there. And then we have to just populate this function here. All right. Now the arg automatically coming into the message, okay, which is an array. All right. So now we're going to check which message it is. We're going to use the switch syntax. All right. So basically switch. Well, I won't go over it in too much detail. Okay, but you know it just goes through the different cases. So it says. Okay, and then it's gonna switch on, which will be the message msg1, the first, that's that tag we inserted, dot as integer. Okay. All right, and then we're going to check the cases. So 0 will be that first thing saying I'm going to send a bunch of stuff. All right, and so when we receive that 0 message, we're going to make a clean array to store our things. We're going to make a buff equals, and we're going to make it equal to 0 because it will just append. Okay, so array are the size 0, new clear 0. So we're going to create a new array that's just 0 size. It's just a empty array. So that's if that first tag is 0, and that's this thing here where we send a 0. We said receive samp 0. I'm sending you lots of stuff. So go ahead and make a clean array to receive. And that's not a semicolon, that's a comma. Okay, because this is still that switch. So then the end switch is here. So basically that's the way it works. I put a semicolon. You get switching on what? On some value that's changing or whatever it comes in. So whatever, if that value here happens to be 0, then it does what's in the curly brackets, this function, which it sets up a new array. Okay, if it happens to be 1, then this is where we pile all those values into that array. We're going to do message. Now, message is an array, right? MSG dot do. So we're going to do something on every value of that array, and it's that same thing. It's the it comes first, and then the x comes next. So the actual value in that message array, and then the index of that value, whatever number slotted number it is. Okay. Then we're going to do an if statement. We're going to say if ix is greater than 1, because the message is containing 0 is containing the name receive samp. Number 1 will be this tag that we're switching on, so we want it to start with 2. Okay, so if ix is greater than 1, okay, that's why we use that. And then this is the if true. Then we're going to stuff those values into this buffer array. So say buf array equals itself. We're just going to add append to it and grow it as we go on. buf array dot add, and what we're going to add is the it. That's the value coming in from that message array. So message dot do, meaning it's going to do every part of that message, which should be this maximum packet size length. So whatever a quarter of that is, so about 10,000 values about. Okay, it's going to say for every one of those 10,000 values, it's going to take whatever's in that value. If it's greater than 1, so it's not going to take the first two, which are, are the tag and the the address, it's going to populate this with the values that come in from it. Okay, that's it. And we have to make sure now all our brackets. This closes the if statement, not the if statement, but the if the what happens, the if action. If it is true, then do this. This closes the if statement, and then this closes the message do loop, and then this closes the switch. Okay, the switch condition, right? And they all turn red, so you see. So if it's 1, that means we're sending stuff. We're going to take everything coming in that message. Okay, so these are separate messages, right? We send these as separate. If it's we send a starting message, we send that as a message. We send each of these arrays as a separate message, and then we send a done message. Okay, so that's how we can do it. So it's going to receive, if it's 0, it sets up the array. If it's 1 for every one, which will be several, it's going to it's 4 per second, about approximately 4 of them. Yeah, well, it is exactly 4 per second. This is a quarter of a second. So if we do something 13 seconds long, it'll send, whatever that 52 arrays. Okay, 52 messages. So every time it takes that, it's going to load this empty buffer array. It's going to append one of these one of the one's messages, append it until it's full. Okay, but you notice that we don't reset it. So every of those 52 or whatever, they just keep coming in, and they just keeps growing and growing until it's the same size as our buffer array. All right, so that's really handy. And then when we're done, let's see, what do we do? When we're done, when we're done, we're gonna change that back to a buffer. Okay, so we're gonna do, when it's done, we're gonna go to that's that tag that says we're all done, and then we're gonna make this thing called new buff2, and it's gonna be equal to a buffer that's being loaded from a collection, which is loaded from this large array that we've assembled. So converted from a float array back into a buffer. Okay, and it's going to be on the server S, and the collection is going to be this big buffer array that we've loaded, buffer array. Okay, tilde buff array. Okay, and then there's some other ones. Number of channels is 1, and then what is this BF stuff? Oh, 1, and then there's an action. Oh, what is BF? Oh, okay, we don't really need the action. I don't know why we do this. But let me put it in there, because this is definitely working, so I'm not sure what this action is. I don't think we need this. But I'm going to stick it anyways, just for, I'm superstitious. I don't want this to break, and then I have to redo this whole video. Okay, all right. So that's 2, and then we don't put a comma on the last condition. So this ends the switch, right? Is that true? Yeah, that ends the switch. Okay, and then this ends the load collection, and then it does an action. And again, I think that's superfluous, but I'm going to leave that in there because this code was working. Okay, so we did all this. Okay, so I think that's us essentially. Okay, so now just to go over this one last time, I created an OSCdef that's going to receive this message, receive SAM, but it has sort of a degree of complexity. It's going to look at the second thing in message, and that's going to be a little tag. If the tag is 0, it's going to set up this empty array. If the tag is 1, it's going to load that empty array. It's going to keep appending to it until all those 1 tags are done. And then if the tag is 2, it says it's all done. Now I'm done loading this array. Now I can convert this array to a buffer, and the buffer is going to be called this new buff2, and that's going to be the one we play back. Okay, so let's set up our all our things here. I'm just going to go ahead and copy and paste all this stuff. You can observe that you don't need me to type through this stuff. I don't think it's just all the things that set up the various parts of this situation. Okay, and I don't have 2 computers here. I have a little video there that I'll post as well that shows me using 2 computers. It's kind of crap, but anyways, it's proof of concept, I guess. And we'll just go ahead and do all this. So hopefully this runs. I might have made some typos. All right, so now's the time to try it. And to be honest, I did it in the code I wrote for the tutorial, and it wasn't working quite right. So I think there just must be a typo or something in there. But the original code that I made works perfectly. So that's posted up here in the GitHub page. This is github.com elosine, ELOSINE. And if you go to the repositories and you find tutorial code, you'll find it under here. Send buffer as array to parentheses 1 SCD. Okay, that's what you want there. All right, just to let you know that it's there. So in case you followed me meticulously, it's not a waste because we learned how to do everything. I think I just put in something extra or something. So let's actually do a proper test now of the code that I know that works. Okay. So I've sent everything here, and I'm going to record something into the buffer. It's kind of a longish buffer. Maybe I'll make it shorter. Let's make it 5 seconds instead. That's enough proof of concept. And we'll record. On top of spaghetti, I'll cover with cheese. I lost my poor meatball when somebody sneezed. Okay, and let's listen to it. When somebody sneezed. Spaghetti, I'll cover with cheese. I lost my poor meatball when somebody sneezed. Okay, we'll do that. Now we're going to run this function, send buff function value. That's how you run functions, and that's that crazy function we wrote. And we'll send it over, and hopefully it's been received. And so this plays back this new buff too, right? This is the my buff, and this is going to play back this new buffer. So somebody sneezed. It works. Covered with cheese. Very good. I lost my poor meatball when somebody sneezed. Okay, so we sent it over, even though it's locally. This could be someone across the world or something. This could be someone somewhere else. So that's successful anyways locally, and I've tried it. I'll upload also the video that shows me working on two computers. Okay, and so let's free that for now. This playback thing. Let's record something else just as for further proof. Batman. Batman. Okay, stop that, and we'll play. That's definitely Batman. Okay, and let's resume playback here. Spaghetti, all covered with cheese. And that's still spaghetti. See? Okay. So there you go. All right. So this has been kind of intense tutorial, but I was really happy with this. So it's a great way if you want to do some sort of interactive performance, or just want to send your buddy some sound files. This is one way you can do it. You record into here and then just send these packets, and they can receive it on the other side, and they could actually become buffer. And then you could do this buffer thing. Even write out back to your hard disk what you recorded. I guess what you received. I mean, it's not that easy, not that hard to send sound files to your friends across the world in email or whatever. But I mean, this is one way you can do. You can pop that over to the network. They can receive it here, and you can use this little nifty thing. You can just take the buffer name, which is new buff 2, and you can do write. And then type in a path. I just happen to have one on my clipboard there. And evaluate that. If I go look in documents, I should have spaghetti there. Oh, when somebody sneezed. Spaghetti, all covered with cheese. And there you go. Okay. Well, good luck with that. Again, it's kind of intense code, but I was happy to have figured that out. And hopefully it's useful.